Greetings. My name is Dr. Corbin Allenbrand, and I have conducted research in blockchain technologies and its application to supply chain management, primarily the issue of information distortion in supply chains, where information distortion is effectively the deterioration of the quality of information that is sent between, let's say, a retailer and a supplier on a supply chain. So blockchain technologies, broadly speaking, are an emerging technology that people are becoming increasingly more familiar with. There are different categories of blockchains, one of which is the public blockchain, which runs the infrastructure for most cryptocurrencies. So on a public blockchain, there's no permission. Any individual with internet access can participate and validate transactions. So a lot of companies do not want this. So architecturally, most supply chain operations over blockchain would occur with some kind of private architecture. So with a private blockchain, users have to get permission or access to validate on the blockchain, so to be participants of it. And going even further, there's a kind of a hybrid approach called consortium. So a consortium blockchain is private in the sense that companies that participate have to be granted access, but what it consists of are multiple firms or companies coming together and designing and maintaining the blockchain. So it's not one company internally that runs it, it's a consortium of companies. So a under-researched and kind of under-emphasized issue with blockchains is how you can even convince companies or firms to participate in it. Because as with any technology, there's a cost of the hardware, of the software, of the training. So with all costs, companies would compare that cost to the benefits. So research has shown, including myself in a paper, that you can actually model the participation in a blockchain architecture as a kind of multi-way game. So game theory is a study of strategic interactions between different agents. So we can model the individual firms as these decision-making agents, and we can model their interaction when it comes to deciding to participate and remain in participation on a blockchain as a strategic game. In particular, I have shown that what is called a prisoner's dilemma can be used to represent a blockchain. And so the blockchain, with its unique properties, actually leads to a slight modification to this game, this set of strategic interactions, such that over enough repetitions of the game, basically transactions between the firms on a blockchain, the benefits of participation can be shown to exceed the cost of non-participation. And so it is the properties of consortium blockchains that allow for the participation to be of benefit to firms. And so my research has shown that in order to actually ensure this participation and the favorable interactions, the blockchain would need to be equipped with what are called smart contracts, which are basically protocols or routines that are set to execute automatically. So this can be the sending of fees or money to one party if another party completes some other action. But my research specifically focuses on if you have two companies in a supply chain that are trying to forecast the demand of a good, this could be a physical product or a service, how can you get them to actually align and agree on the forecasts they're generating and thus the amount of product or service they each provide so that they are kind of coordinated? Well, smart contracts on consortium blockchains provide that coordination mechanism. And it's through the coordination via the smart contract that strategic interactions between supply chain members is favorable. So overall, smart contract enabled consortium blockchains can lead to a strong enhancement in the transmission and quality of information over supply chain networks. This is Corbin Allenbrand, signing off.